So let's first start by dividing a monomial, right? If you're going to divide a monomial, you're going to divide each monomial of the polynomial by the monomial in the denominator. So look at what we have here. I've got a polynomial divided by a monomial. So basically each one of these gets divided by the denominator, right? So essentially what that looks like is you have the first term divided by 4CDF minus, right, because there is a minus there, the second term divided by this, and then plus 4CDF divided by 4CDF. Okay? And then we are going to now get here 5C cubed D minus 4 just F plus 1. Okay? So this part is similar to what we did yesterday, like if you separate them, right? Once you separate them, that's like what we did yesterday. Okay, now, what if you have a polynomial, but now you have to divide it by more than one term? Well, here you've got two options, and the options are either long division or what we call synthetic division. Okay, so for long division, we have to go all the way back to 4th and 5th grade. And remember how we did long division back then, way back then. So you have this one, 789 divided by 4. Remember how we set up a long division, right? It looks like this. Yeah? And then you said, okay, 4 goes into 7, or 7 divided by 4 is at most 1, right? Then what do? 1 times 4, right? And then you subtract, and you get a 3. And now you bring down the 8, and then the process starts again. So 4 goes into 38, how many times? 9 times. Then you multiply 9 times 4. You subtract, you get a 2, and then you bring down the 9, and you do it all over again. 7, 28, you get a 1, and that's the remainder. Okay? Okay. So, that's what we're going to do. We're going to divide this long division to find each quotient. So same thing, one divided by the other. This x minus 3, that's like the 4 from before. That goes out there. Sorry, not with that parentheses. It's the one that's it does matter. It's the one that you're dividing by. So 789 divided by 4, right? It's that number. We call that a divisor. Here, I mean, it doesn't have to be the smaller number, but it's the one that, is being divided by, okay? And this one here, x squared plus 7x minus 3, that's called the dividend. That's what you're dividing. Oh, minus 30. That's the dividend. That's what you're dividing. So that's how we set this up. Okay, now, to do this, here's what you have to do. You have to see how many times basically x minus 3 goes into the first term, right? But the way we do it for the polynomial, here's how I like to do it. Take the first term and the first term, right? If you divide them, what do you get? X. So x goes there. And for the long division, what did we do once we had a number there? You multiplied by the thing at the left, right? So now we're going to do x times x minus 3. What are we going to get? X squared minus 3x. Then what did we do? Subtracted. Okay, so subtracting, right, is like changing the sign. So this becomes x squared minus x squared. But if I were to subtract this, what happens to it? It'll be 7 minus this, so 7 plus 3x, correct? So subtracting is the same as changing the sign. So we can basically you change the sign and then you do this. So here is like the mnemonic, right? In order to do this, you draw the line, change the signs, and combine. Draw the line, change the signs, combine. So this goes away. And then here we have 10x. Okay, you have 10x, right? Now the minus 30 comes down and the whole process starts over. So now let's do it again. First term over first term gives you what? 10. Positive 10 goes there. You multiply, what do you get? 10x minus 30. Then you're going to draw the line, change the signs, and combine. And that will give you a 0. So this has a remainder of 0. So your quotient is x plus 10. Yeah.
So after you do x squared divided by x minus 3, is 7x included in that part? And you just do 7x squared for each?
No, once you multiply this, x squared minus 3x, you align it, the x squares and the x's together. And now the 7 combines with this, and then you're done.
So
now you get.
The 7x is the dividend along with the 30.
Yes. Okay. So now let's do this next one. This next one, it looks like it's a multiplication, but it's not, because this has a exponent of -1. So we can write it as x squared minus 13x plus 12 over x minus 1, right? So now it's the same situation. It's one thing divided by another. So x minus 1 goes here, and then I got x squared, negative 13x, positive 12. Okay, so let's do this mentally now. First term divided by first term, what do I get? X, multiply it through, I get x squared minus x. Draw the line, change the signs, combine. I get negative 12x, right? Then what happens? Bring down the 12. Okay, first term divided by first term, what do I get? Negative 12. Multiply. Okay. Draw the line, change the signs. What do we get? 0. So the quotient is x minus 12. Because to subtract, that's what it is, right? If you have like... Right, because for long division, you subtract all the time, right?
Yeah.
Okay. Here's another one, yeah.
Is it possible to like end like the whole like thing with like a x or something?
Yes, yes, when you have a remainder. We're gonna get there. Okay, so take a look at this one. Let's use long division again, right? So now we've got some more terms. Okay, so x plus 3 goes here. 2x cubed, 3x squared, negative 4x plus 15. Okay, first term divided by first term gives me what? Is that right? This divided by this? Yes? So it's this one inside over x gives you 2x squared. Okay, multiply 2x cubed plus 6x squared. Subtract by changing the signs. 3 minus 6 is negative 3x squared. Now this comes down. Okay, so one more time. This divided by this. This divided by this. What am I going to get? Negative 3x. Multiply. We're going to get negative 3x squared. Negative 9x. Okay, look, let me have you look up here for a minute. Do you see how every time you multiply, the x squares are aligning with the x squares and the x's, so the common terms are aligning with each other. It's happening naturally now, but there are going to be problems where that might not happen naturally. Be mindful that you align like terms in the same column, okay? Change the signs and combine, and we get what? 5x, and the 15 comes down. Now, first term divided by first term, what do I get? Positive 5. Multiplying, I get 5x plus 15. Change the signs, and the remainder is 0 again. Okay? All right. So the quotient again is this. Okay, now, like we talked about before, this term that that is in the numerator, that's the dividend. That's what you're dividing, right? That's the dividend. This is the divisor. And then when you do your operation, when you do the division, your answer is the quotient. You guys learn all this in like elementary school and you forget. You only remember quotient. When we write the final answer, if there is a remainder, when you write the final answer, the way you write it is the quotient is written first plus whatever remainder you get over the divisor. Okay? All right. So now, next we're going to learn synthetic division. Okay? You know how we eat like turkey and then there's like tofurkey, right? It's like the tofu version of turkey. Synthetic division is like the tofurkey of division, right? So here we go. To do synthetic division, you're going to write the coefficients of the dividend of f of x of the numerator so that the terms are in descending order. So for example, take a look here. This is your dividend. This is the f of x that you're dividing. First, check to see that the exponents are in decreasing order. X to the power of 3, 2, 1, 0. Okay, now write the coefficients. 3, 5, -1, 4. Here, 3, 5, -1, 4 as separate entities. Then, this term here, the x plus 1, you set it equal to 0 and you get x equals -1 basically, right? That -1 is what goes here. Okay, so now we've set this up. Now, the first term, the 3, comes down for free. Okay, synthetic division works like this. Anything that makes it down to the bottom gets multiplied by the number outside to the left. So 3 times -1, you get -3. You add these two, and you get 2. Whatever makes it down here gets multiplied by -1. So this becomes -2. You add those two, what do you get? -3, and then +3. So what do you get? 7. Okay, now, okay, so I know I have like a whole page, but I just wanted to just do it with you guys because I know you guys are quick with this. Okay, so what did we get now? What did we get now? Let me fill it in quickly. So what did we get here? We got 3, 2, -3, 7. Now, huh? No, this is right. It's a 3. Okay, this last number is always the remainder. Okay? This gives you the coefficients of the quotient. All right? So now, what was our initial problem? It was 3x cubed plus 5x squared minus x plus 4 all over x plus 1. Remember, that was the initial problem. So now we divided this. We got a quotient. These are the coefficients of the quotient. What was the degree here? 3. When you divide something, the degree is always reduced by 1. So now the highest exponent is going to be a 2. Okay, so you see this 3 here? It's going to be that quotient times x to the power of 2. No, it's x plus 1.
No, it's x plus 1 because you have the equal to 0.
Yeah. Okay, so look, 3x squared plus the next coefficient, x to the power of 1, plus the next coefficient, which is a negative 3. All right, so do you see how that happens? Another way to do it is, these are the coefficients of the quotient. You started with x cubed, it's going to go down 1, so it's like you're going to have an x squared, an x to the 1, an x to the 0 here. Okay, now we're not done yet. We still have a remainder. The remainder is 7, so you do plus 7 over x plus 1, the divisor. Okay? All right, so let's do a couple more. Yeah.
How do you get 2x minus 3?
Okay, you see these numbers? They're those coefficients.
So
okay, so let's do another one and then it'll like sink in. Let's do another one. Okay, take a look at this first one. You have, first arrange your exponents. You have a to the 4, you're missing an a cubed, and then you have a squared, a to the 1, a to the 0, right? Okay, you're missing an a cubed, but otherwise, they're in order. So here's what you're going to do. When you make your synthetic division chart, you're going to put in the 4, but for the missing term of a cubed, it's going to be a 0. You've got to put in the 0 if you want the right answer. If you don't care about getting it right, you can go ahead and leave the 0 out. Okay, so now we put 2, negative 4, 12. Here's what I always do. Exponent of 4, right? 4, 3, 2, 1, 0. That's always got to happen. You have to start from the highest, and you have to have 1 for each until you reach 0. Okay? What goes out here in the front to the left? Negative 2. Okay. First number comes down for free. Multiply, what do we get? Negative 8. Add, negative 8. Multiply, add, multiply, negative 36. Add, negative 40. Multiply, I get 80. Add, I get 92. Okay, so let's write down the quotient. I'm not going to write the initial problem first. Okay, so this is the remainder. The quotient is going to be, all right, so what's going to be the highest exponent now? 3. We started with an a to the 4. Now it's going to be a to the 3. So first coefficient, 4a cubed minus 8a squared plus 18a minus 40 plus 92 over what? X plus 2. Oh, a plus 2, sorry. Okay? Yep. Yes.
Wait, can you explain why we needed to do 0 then?
Yes, because this only works if all of the exponents are represented from the highest one to the 0. If you look at this, you have an exponent of 4, missing a 3, and then it goes to a 2. All of them have to be represented. So take a look at this next one. It starts with 4, then we have 3, then we've got 2 of them missing. So we got to put even more zeros. So it's going to be 6, negative 8, 0, another 0, negative 14. And then you're like, wait a minute, did I even do that correctly? Well, let's count. Exponent of 4, 3, 2, 1, 0. Yeah.
I was going to ask, like, if it's divided by, like, x plus something, is the answer always going to be, like, positive, negative? causes negative?
It also depends on what the initial signs are.
Yeah.
Like this one here was, right? So it depends on what the signs of the divisor are as well, and the dividend. Right?
How is 14 have an exponent of 0? Negative.
Huh?
How does negative?
Because it's technically b to the 0. That's how we get just negative. I mean, b to the 0. That's how we get 14. Okay, so 6. What's next? 12. And then, what else do I write? 4. And then 8. And then, well, first 8 and then 16. 16. 32. 18. Okay, so it's 6 times b to the what? 3 plus 4 times squared, 8b to the 1, and then plus 16 plus 18 over b minus 2. Yeah.
Why did you use b to the 4?
Yeah,
Wait, what?
why do you skip B?
Okay, because it started with b to the 4. Now we divide it, and anytime you divide, like if you have b to the 4 divided by b, you're going to end with a b cubed, right?
So it's always 1.
So it's always going to get reduced by 1 because this is b to the 1. Okay?
Can it ever be B to the 2? We're not doing that yet.
We're not doing that. Okay, now let's see how synthetic division compares with long division. Okay? Ready? All right. So we're going to divide this using long division. 2x plus 1 goes out here. And then this gigantic f of x is going to go over there. Now look. Here too. I've got an x to the 4 missing an x cubed, yeah? You're going to have to compensate for that as well. So I have 8x to the 4 plus, because this one has the variables, we're going to have 0x cubed. And then continue.
Is it always plus?
Yeah, because it's 0. It doesn't really matter. Okay, we're good? All right. So now, let's go ahead and start. First term divided by first term. What am I going to get? 4x cubed. Multiply, you get 8x to the 4 plus 4x cubed. Notice, every single time, because we're dividing this first and then multiplying, every single time, these two have got to be the same. Now, change the signs and add. I'll get your question in a second. Change the signs and add them. Oh my God, I'm so sorry. I didn't even see you. Go, go, go. Here, I'll open the door. That's two today because it's so dry. Go to the bathroom. Get some paper towels. You know where the closest bathroom is? Okay. All right. When it's so dry.
I've never blushed my nose. Me too.
Huh? So, subtract. This goes away. Negative 4x cubed. Minus 4x squared comes down. Okay, tell me, what am I going to put on top?
Oh, I have negative 2x squared.
Negative 2x squared. Okay, so we get negative 4x cubed minus 2x squared. Change the signs. I get negative 2x squared plus x. Okay, it's this divided by the first term. Negative 2x squared over 2x, negative x. Multiply. Change the signs and add. That goes away. What do I get left? 2x plus 4. What do I put on top now? 2x divided by 2x? 1. 1 or 2? 1. 2x plus 4. Change the signs. And I get Oh, sorry, this was a 1. Remainder of 3. Okay, so now the answer is going to be the quotient, which is here, right? So 4x cubed minus 2x squared minus x plus 1 plus 3 over 2x plus 1. Okay, now we're going to do the same problem using synthetic division, and we're going to see if there is a difference. Well, let's see. Okay, so what numbers are we going to put in here? 8? You okay?
Yeah.
Okay.
8-0.
8, 0. Yep. 1, 4. Now, here we take the 2x plus 1, set it equal to 0, x equals negative a half. Okay. Oh my God. No. Stop. Everybody stop. Oh my God, the nose bleeds. It got me. Okay. Sorry, hang on. I'm so sorry. I did such a rookie thing. Okay. Sorry. Oh my God. I got in my zone. Sorry, guys. Sorry. I know. I'll tell you. So look. When this has a coefficient other than 1, you have to divide everything by 2, right? Everything by that number. So you're going to divide this by that number. But then you also have to divide all of these by that number. Why? Why do we have to do that? Because initially, this is like that first parentheses over the second parenthesis, right? Well, if I divide this by 2, that won't work. I have to do the same thing to the numerator as well, right? Otherwise, like I'm changing the problem. So now I have a new set of functions. Now I got 4x squared minus 4x to the 4 minus 2x squared plus half x plus 2 divided by x plus a half. You have got to do this. Okay? Don't be like me and forget. Yeah. It'll come back. Okay, so now we got the 4, 0, negative 2, a half, a 2, and negative 1/2 out here.
Okay. What if it's 2x plus 2? Do we have to divide everything by 2, or can we just make it 1 because...
No, whatever. You always have to divide by that coefficient. Just like with the completing the square, we had to take out the coefficient. Remember, it's the same. So 4 comes down. Multiply by a negative half, I get negative 2. Multiply, I get 1. Negative a half. Nope, positive a half. I get 1. Multiply by negative half. And finally, I get 3 over 2. Any questions? Okay, so now this is the remainder. This is the quotient. By the way, that blue that I've highlighted, that's also called, technical terms, the depressed polynomial. But it's got nothing to do with an emotional state. It's just because it's like depressed, right? It's like pressed down. It's like a French press, right? So it's going to be 4x to the what? 3 minus 2x squared minus x plus 1 plus, okay, 3 over 2 over x plus a half. But now you're like, wait, that doesn't look the same as that. Yes, it does, because now we have to simplify this. We can't have a complex fraction, right? So what's that going to be? Right, 4x cubed minus 2x squared minus x plus 1 plus 3 over this 2 comes to the bottom and it distributes into here. So you get 2x plus 1. Okay? So is everybody okay with that, or should I do that a little bit more slowly?
I just need like the last part.
Yeah, me too. I don't get like the 3 over 2.
Okay. Let's just focus on this one and then I'll take your question. Look at what we had here. We had 3 over 2 divided by x plus a half, right? This is the same as 3 over 2 times x plus a half. Yes or no? Let's write it in another way. This is the same as the first fraction divided by x plus a half. Divided by x plus a half is the same as times 1 over x plus a half. Okay? Now, the numerator is 3. The denominator is 2x plus 1. Okay? So you see how with the long division and with the synthetic division, we get the same answer. One is longer, hence long division. One is not as long, okay? The thing with this is it's much quicker because it eliminates a lot of the variables and, you know, all of that stuff. It's very, very quick. You've got to not pull what I did and remember that when this has a coefficient other than 1, divide everything, okay? Another thing is synthetic division, right? We're only going to use synthetic division for for linear terms, right? If this is a linear term, we're not going to use it for non-linear. Okay, so you do it only when you're dividing by something to the power of 1. Make sense?
What is an example?